In this example, we're going to solve the system by elimination, also known as the addition method. So recall step 1 is to make sure your equation is in standard form, which both equations are. Step 2 then is to look for a variable term that has a coefficient of 1 or -1. And so both for equations number 1 and number 2, we see that the y's have a coefficient of 1. So it would be easiest to eliminate your y's rather than your x's. And we can accomplish this by simply making one of them their opposite, because they're not going to eliminate the way they are because they have the same signs. So we have to change the sign of one of them to their opposite so that our y's can be eliminated. I'm going to go ahead and just choose the first equation. It doesn't matter which one you do as long as you change the sign of one of the y's. And to do that, you're going to have to multiply the whole entire equation by -1. So we're going to go ahead and distribute that -1 to each term so that we multiply. That's going to be -1 times 2x, and then -1 times positive y, and then lastly -1 times -6. So when we do that and rewrite that first equation, we're not going to do anything to the second equation. It's going to look like so. And so on the next page, where we have more room, we're going to go ahead and proceed with the addition, lining them up and adding the two equations together. So now that we have the two equations, we're going to add them. Notice when we add our x's, that's going to give us a x, because subtract, take the sign from the larger number, will just give us an x. Our y's canceled out. That was our mission, and we accomplished our mission. They're gone. On the right side with your constants, you have signs that are different. Subtract, take the sign from the larger number, is going to give you a -4. And so x equals -4. Now the next step is we're going to take that x for -4 and plug it into either of the original equations so that we can find out what our y value is. Now let's plug -4 for x into either of the equations to determine the value for y. So into the first equation, we're going to remove the x and replace it with -4. Now we have to do the math. Order of operation, multiplication, 2 times -4 is -8. Next step to solving for y is to add 8 to each side, and y equals 2. So our solution then is -4, 2. Now for those of you who plugged x into the second equation, it's going to look like so. Removing the x and replacing it with -4 is going to look like so. 3 times -4 is -12. Last step to solving for y is to add 12 to each side. And again, y is 2, so our solution is -4, 2. Now recall, step 6 is optional. And step 6 just ensures whether the answer you have is indeed your answer. All you have to do is plug your ordered pair back into either of the equations. If it leaves you with both sides being the same, meaning that's a true statement, then that is your proof that it is a solution. So we're going to go ahead and plug our solution of -4 for x and a 2 for y into the first equation and then do the math. So 2 times -4 is -8. -8 combined with a +2 does give me a -6, so that does check out. Both sides are the same, and that is a true statement. If you decide to plug it into the second, you will get the same answer of a true statement. So let's go ahead and plug in a -4 for x and a 2 for y into the second equation. So 3 times -4 is -12. -12 combined with a +2 is going to give you a -10. Again, it leaves you with a true statement, meaning both sides are the same. So that is your proof that your solution is indeed -4, 2.